Welcome to Tech with Kaushik. This is part 4 of our complete practice question series for the AZ-400 Microsoft Certified DevOps Engineer Expert exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 4. Question number 129. Scenario. An Azure Pipelines release deploys only commits from the protected production branch. A custom external scanner reports a commit status after validating each pull request. Merging must be blocked until the scanner reports success. Which configuration should you implement? The available options are as follows. Option A. Add the external status check to the production branch policies. Option B. Add the status check only to developers' feature branches. Option C. Create a project service hook without a branch policy. Option D. Restrict release pipeline job authorization to the current project. The correct answer is option A. Add the external status check to the production branch policies. Here's why. A required status policy on the protected target branch prevents pull request completion until the custom scanner posts a successful status for the change. Why are the other options not correct? B. A policy on feature branches does not enforce the merge into production. C. A service hook can invoke integration logic, but does not itself block the merge. D. Job authorization scope limits pipeline token access and does not create a security validation gate. Exam tip. Use a required status policy when an external system must approve a pull request before merge. Question number 130. Scenario. You have an Azure DevOps subscription that contains the following projects. Project 1. 100 users. Project 1 Public Repository. Public Visibility Project 2. 5 users. Project 1 Public Repository. Public Visibility Project 3. 2 users. Private GitHub Repository. Private Visibility Project 4. 1,000 users. Public GitHub Repository. Public Visibility Project 5. 150 users. Public GitHub Repository. Private Visibility. You build apps for the projects by using Azure Pipelines. Which 2 projects meet the criteria for granting free parallel jobs? Each correct answer presents part of the solution. Select exactly 2 answers. The available options are as follows. Option A, Project 1. Option B, Project 3. Option C, Project 4. Option D, Project 2. Option E, Project 5. The correct answers are Option A, Project 1, and Option C, Project 4. Here's why. Azure Pipelines provides a generous free tier of parallel jobs specifically for public projects, up to 10 free Microsoft-hosted parallel jobs. Project 1 and Project 4 are explicitly configured with public visibility, making them eligible for these free public parallel job grants. Note, Project 2 is also public but shares the exact same repository and scope as Project 1, making Project 1 and Project 4 the primary distinct public projects in this scenario. Why are the other options not correct? B. Project 3 is a private project and only qualifies for the standard 1 free parallel job, 1,800 minutes per month, not the unlimited/expanded free parallel jobs granted to public open source projects. D. While Project 2 is public, it is essentially a smaller subset of Project 1's repository. Project 1 and Project 4 are the primary intended answers for distinct public repositories. E. Project 5 is a private project and does not meet the criteria for public project free parallel jobs. Exam tip. Remember that Azure Pipelines grants up to 10 free Microsoft-hosted parallel jobs with unlimited minutes for projects configured with public visibility. Question number 131. Scenario. You have an Azure Pipelines pipeline that has the following definition. Jobs, job, a steps, hashtag job A steps here job, B depends on. Steps, hashtag job B steps here job, C depends on. Steps, hashtag job C steps here job, D depends on. C steps, hashtag job D steps here. For each of the following statements, select yes if the statement is true. Otherwise, select no. Statement 1. Job B can run concurrently with job A. Statement 2. Job D can run concurrently with job B. Statement 3. Job C can run concurrently with job D. Statement 1. Job B can run concurrently with job A. The answer is yes. Neither job has dependencies on each other, so they run in parallel. Statement 2. Job D can run concurrently with Job B. The answer is yes. Job D depends on C, not B. They can execute at the same time. Statement 3. Job C can run concurrently with Job D. The answer is no. Job D explicitly depends on Job C and must wait for it to finish. Exam tip. In Azure Pipelines YAML, jobs run concurrently by default. Using depends on explicitly removes any implicit stage dependencies, ensuring parallel execution. Question number 132. Scenario. A GitHub Actions workflow builds, tests, and releases an application. Tests must start only after the build succeeds. Production deployment must require approval from the change advisory team. Select the GitHub Actions construct that satisfies each requirement. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Model the build and test phases as dependent the blank. The choices for Statement 1 are packages, matrices, or jobs. Statement 2. Protect production by configuring required reviewers on in the blank. The choices for Statement 2 are pull requests, environments, or packages. For Statement 1, the correct selection is jobs. Job dependencies, implemented with needs, enforce execution order and success gating. For Statement 2, the correct selection is environments. Environment protection rules provide deployment approvals. Exam tip. Use jobs and needs for workflow sequencing. Use protected environments for deployment approvals. Question number 133. Scenario. A classic Azure Pipelines release definition contains a temporary stage named Sandbox Cleanup. A contractor must be able to delete only that stage after validation ends. At which permission scope should the contractor be granted the required permission to follow least privilege? The available options are as follows. Option A, project. Option B, stage. Option C, organization. Option D, pipeline. The correct answer is option B, stage. Here's why. Granting the delete stage permission on the specific sandbox cleanup stage limits the contractor's authority to the single object that must be removed. Why are the other options not correct? A. Project scope affects many project resources. C. Organization scope is substantially broader. D. Pipeline scope can affect the full release definition rather than only the temporary stage. Exam tip. For least privilege, choose the narrowest object-level permission scope that supports the required action. Question number 134. Scenario. A GitHub Actions workflow deploys a data service and must read a database password stored as a secret in Azure Key Vault. The workflow will authenticate to Azure by using a Microsoft interest service principle. Drag the 3 required actions to the destinations in the order in which they should be performed. 3 source items are used. The available source items are as follows. Source item 1. Grant the service principal permission to read secrets from the Key Vault. Source item 2. Create a GitHub personal access token for repository administration. Source item 3. Create the Microsoft interest service principal. Source item 4. Add the Key Vault retrieval and secret reference to the workflow. Source item 5. Grant cryptographic key permissions on the Key Vault. The destination requirements are as follows. Destination A. First action. Destination B. Second action. Destination C. Third action. The first correct mapping is create the Microsoft interest service principal, mapped to first action. The second correct mapping is grant the service principal permission to read secrets from the Key Vault, mapped to second action. The third correct mapping is add the Key Vault retrieval and secret reference to the workflow, mapped to third action. Here's why. The identity must exist before access can be granted. After the principal receives secret read permission, the workflow can authenticate as that identity and retrieve the database password. Exam tip. Identity creation precedes authorization, and authorization precedes secret retrieval. Question number 135. Scenario. An Azure Pipelines YAML definition builds a GitHub repository and must start only for pull requests that change files under src/portal. A developer proposes the following configuration. Trigger. Branches. Include. Refs/heads/pull paths. Include. src/portal/***. Does the proposed configuration meet the requirement? The available options are as follows. Option A, no. Option B, yes. The correct answer is option A, no. Here's why. The trigger key configures continuous integration pushes, not pull request validation. A pull request trigger must use the PR section with the required path filter. Why are the other options not correct? B. The configuration can start for branch pushes and does not correctly express the required PR-only behavior. Exam tip. In Azure Pipelines YAML, trigger controls CI pushes and PR controls pull request validation where YAML PR triggers are supported. Question number 136. Scenario. An Azure Pipelines YAML definition builds a GitHub repository and must run only when a pull request modifies content in services/web. The following YAML is proposed. Trigger, branches, include, PR paths, include, services/web/***. Does the proposed YAML satisfy the requirement? The available options are as follows. Option A, yes. Option B, no. The correct answer is option B, no. Here's why. Using trigger with a branch named PR does not define a pull request trigger. The pipeline requires a PR section with a paths include filter for services/web. Why are the other options not correct? A. The YAML describes a CI branch filter, not the required PR event filter. Exam tip. A branch value called PR is not equivalent to the YAML PR trigger keyword. Question number 137. Scenario. An Azure Pipelines definition builds a GitHub repository and should validate pull requests to main only when files below app/frontend change. A developer adds PR branches include app/frontend/*** paths include refs/head/main. Does this configuration meet the requirement? The available options are as follows. Option A, no. Option B, yes. The correct answer is option A, no. Here's why. The branch and path filters are reversed. Refs/heads/main belongs in the branch filter, while app/frontend/** belongs in the path filter. Why are the other options not correct? B. Although the PR key is correct, the filter values are assigned to the wrong properties and therefore do not express the requirement. Exam tip. Branch filters identify target branches. Path filters identify changed repository paths. Question number 138. Scenario. A legacy PowerShell onboarding script registers the change analysis resource provider and adds the hidden web app scan tag to every app service application in a subscription. Complete the two command fragments used by the script. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. To register the provider, run the blank Microsoft.change analysis. The choices for Statement 1 are new Azure role assignment, object type, register a resource provider, provider namespace, or register Azure provider feature, provider namespace. Statement 2. To persist the modified tag collection, run the blank $webapp.id, tag $tags, force. The choices for Statement 2 are invoke Azure resource action, resource ID, set AZ policy assignment, identity ID, or set as a resource, resource ID. For Statement 1, the correct selection is register as a resource provider, provider namespace. This complete registers an Azure resource provider namespace. For Statement 2, the correct selection is set as a resource, resource ID. This complete writes the updated tags to the identified resource. Exam tip. Provider registration and resource updates are separate operations. Feature registration is not a substitute for provider registration. Question number 139. Scenario. An engineering team uses GitHub for source control and Azure Boards for work tracking. A developer must associate a GitHub commit with Azure Boards work item 742. Which two methods create the required development link? Select two answers. The available options are as follows. Option A. Include AB number 742 in the GitHub commit message. Option B. Add a work item comment that contains only the commit URL. Option C. In the work items development section, add a link to the GitHub commit URL. Option D. Include AZ-400 in the GitHub commit message. Option E. In the links section, add an existing item link and paste the commit URL. The correct answers are Option A. Include AB number 742 in the GitHub commit message, and Option C. In the work items development section, add a link to the GitHub commit URL. Here's why. AB number 742 creates the Azure Boards Association automatically when GitHub integration is configured. The development section also supports manually linking the commit by URL. Why are the other options not correct? B. A comment containing a URL is not a development link. D. AZ-400 is not the Azure Boards work item reference syntax. E. Existing item links connect work items and do not create the GitHub commit development link. Exam tip. Use AB hashtag work item ID for automatic traceability between GitHub activity and Azure Boards. Question number 140. Scenario. A product team is reviewing delivery feedback. Customers discover most defects after release, and operations often notices service failures long after they begin. Select the metric that directly measures each problem. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. To measure defects that escaped internal validation and reached customers, review the blank. The choices for Statement 1 are mean time to recover, defect escape rate, application failure rate, or bug report rate. Statement 2. To measure how long failures remain unnoticed, review the blank. The choices for Statement 2 are mean time to detection, defect escape rate, mean time to recover, or application failure rate. For Statement 1, the correct selection is defect escape rate. It directly quantifies defects that pass through earlier quality controls. For Statement 2, the correct selection is mean time to detection. It measures the delay between failure occurrence and detection. Exam tip. Escape rate is a quality leakage metric. MTTD is an observability and detection speed metric. Question number 141. Scenario. An automation utility updates GitHub Actions encrypted secrets through the GitHub REST API. The utility retrieves the repository public key before sending each encrypted value. Which library should the utility use to encrypt the secret value in the required sealed box format? The available options are as follows. Option A, Hashlib. Option B, libsodium. Option C, Bouncy Castle. Option D, CryptoNet. The correct answer is Option B, libsodium. Here's why. GitHub REST endpoints for encrypted secrets require client-side encryption by using a libsodium sealed box and the public key returned by GitHub. Why are the other options not correct? A. Hashlib provides hashing, not the required reversible public key sealed box encryption. C. Bouncy Castle is not the library specified by GitHub for this payload format. D. CryptoNet is not the required GitHub secret encryption library. Exam tip. GitHub encrypted secret API calls use the repository or environment public key with libsodium sealed box encryption. Question number 142. Scenario. A repository uses GitHub Actions to run OWASP ZAP against a staging website. One workflow must perform a short spider and passive scan without attacking the site. A second workflow must run the traditional spider, optionally run the AJAX spider, and then perform active scanning. Choose the ZAP action for each workflow. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Use the blank for the passive-only workflow. The choices for Statement 1 are ZAP Full Scan, ZAP API Scan, or ZAP Baseline Scan. Statement 2. Use the blank for the workflow that includes active scanning after spidering. The choices for Statement 2 are ZAP Baseline Scan, ZAP Full Scan, or ZAP API Scan. For Statement 1, the correct selection is ZAP Baseline Scan. Baseline scanning is designed for passive checks and does not perform active attacks. For Statement 2, the correct selection is ZAP Full Scan. Full scanning supports spidering followed by active attack testing and optional AJAX spidering. Exam tip. Baseline is passive. Full performs active DSD. API scan targets API definitions. Question number 143. Scenario. After installing the Microsoft Security DevOps extension, a team creates a starter Azure Pipeline's YAML definition on a branch named Security Scan. The pipeline must execute the extension with the Azure DevOps policy and publish the serif results. Complete the security scanning step by using the currently supported task inputs. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Set the task to the blank. The choices for Statement 1 are Publish Security Analysis Logs at 3, Microsoft Security DevOps at 1, or Advanced Security Codec Init at 1. Statement 2. Set Policy to the blank. The choices for Statement 2 are None, Azure DevOps, or Microsoft. Statement 3. Set Publish to the blank. The choices for Statement 3 are False or True. For Statement 1, the correct selection is Microsoft Security DevOps at 1. This is the task contributed by the Microsoft Security DevOps extension. For Statement 2, the correct selection is Azure DevOps. This selects the supported Azure DevOps policy. For Statement 3, the correct selection is True. Publishing exposes the normalized serif results as a pipeline artifact. Exam tip. Validate extension inputs against the current task version. Older examples can contain removed parameters. Question number 144. Scenario. A pipeline must compile an application, run API and database test stages in parallel after compilation succeeds, and then aggregate results after both test stages finish. The aggregation stage must run even when either test stage fails, but not when the pipeline is canceled. A developer proposes the following stage graph. Stage, compile stage, API test depends on, compile stage, database test depends on, compile stage. Aggregate results. Does this stage graph satisfy all requirements? The available options are as follows. Option A. Yes. Option B. No. The correct answer is option B. No. Here's why. Aggregate results has no explicit dependency on both test stages and uses the default success condition. It can depend only on the immediately preceding stage and will not run after a failed test stage. Why are the other options not correct? A. The two test stages can run in parallel after compile, but the aggregation stage does not wait for both and is not configured with succeeded or failed. Exam tip. For a fan-in stage, list every upstream stage and depends on, and set the condition required for failed dependencies. Question number 145. Scenario. An Azure Pipeline's job produces JUnit files. The publishing task must run after successful or failed preceding steps, publish the files, and fail the pipeline whenever the published test run contains failed tests. The team configures task, publish test results at 2 condition, succeeded or failed. Inputs, test results format, JUnit test results files, ***, /JUnit, XML, fail task on failure to publish results. True. Does this task meet every requirement? The available options are as follows. Option A. Yes. Option B. No. The correct answer is option B. No. Here's why. The task runs after success or failure and attempts to publish results. But fail task on failure to publish results fails only when publication fails. It does not fail the task because tests failed. Why are the other options not correct? A. The requirement needs fail task on failed tests. True, which is absent from the proposed task. Exam tip. Distinguish a failed test run from a failure to upload or publish the test result files. Question number 146. Scenario. A team uses this Docker file for a web API. From mcr.microsoft.com/.net/spnet:8 A0AS runtime worker/app expose 8080 from mcr.microsoft.com/.net/SDK:8 A0AS build worker/src copy. Run.net build web API docsproj. See release. o/app/build from build as publish run.net publish web API docsproj. See release. o/app publish from runtime as final workter /app copy from equals publish /app /publish entrypont.net web api.dll. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. The Docker file uses multiple build stages. Statement 2. The application is compiled by using the debug configuration. Statement 3. The final image hosts an ASP.NET Core application. Statement 1. The Docker file uses multiple build stages. The answer is yes. Several named from stages are used and artifacts are copied from publish into final. Statement 2. The application is compiled by using the debug configuration. The answer is no. Both .NET Build and .NET Publish specify see release. Statement 3. The final image hosts an ASP.NET Core application. The answer is yes. The final stage is based on the ASP.NET Core runtime image and starts web api.dll. Exam tip. Read every from instruction and each C argument when evaluating a multi-stage .NET Docker file. Question number 147. Scenario. A new Azure repos Git repository will build an ASP.NET application. The default main branch might not exist. The YAML pipeline must be created from the ASP.NET template and saved to a new branch named CI Bootstrap. Arrange the actions in the order in which they should be performed. The available items are as follows. Item 1. Select the ASP.NET pipeline template. Item 2. Save the generated YAML to the CI Bootstrap branch. Item 3. Initialize the repository's default main branch when it is absent. Item 4. Select the target Azure repos Git repository. Item 5. Start a new pipeline and choose Azure repos Git as the code location. The correct sequence is as follows. First, initialize the repository's default main branch when it is absent. Second, start a new pipeline and choose Azure repos Git as the code location. Third, select the target Azure repos Git repository. Fourth, select the ASP.NET pipeline template. Fifth, save the generated YAML to the CI Bootstrap branch. Here's why. A repository needs a default branch before Azure pipelines can create the YAML. Pipeline creation then proceeds from code location to repository to template, followed by saving the generated file to the requested branch. Exam tip. For portal-based YAML creation, establish repository content first, then select source, repository, template, and save destination. Question number 148. Scenario. A deployment creates an Azure Monitor action group that must be usable by alerts from any Azure region. Two named administrators must receive direct email notifications, and members assigned the built-in owner role at the monitored resource must also be notified. The common alert schema must be enabled only for the role-based receiver. Complete the action group configuration. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Set the action group region to the blank. The choices for Statement 1 are resource group location, global, or East US. Statement 2. Add the two named administrators by using the blank notification type. The choices for Statement 2 are Azure Resource Manager role, email/SMS message/push voice, or webhook. Statement 3. Notify resource owners by using the blank notification type. The choices for Statement 3 are Azure Function, email/SMS message/push voice, or Azure Resource Manager role. Statement 4. For the direct email receiver, set the common alert schema to the blank. The choices for Statement 4 are enabled or disabled. Statement 5. For the role-based receiver, set the common alert schema to the blank. The choices for Statement 5 are disabled or enabled. For Statement 1, the correct selection is global. A global action group can be used by alerts originating in any Azure region. For Statement 2, the correct selection is email/SMS message/push voice. This notification type supports explicit email address receivers. For Statement 3, the correct selection is Azure Resource Manager role. This receiver targets members of a supported built-in Azure or BAC role. For Statement 4, the correct selection is disabled. The requirement limits common schema use to the role-based notification. For Statement 5, the correct selection is enabled. Owners must receive the common alert schema. Exam tip. Action groups can mix direct receivers in Azure or BAC role receivers, with schema settings configured per receiver. Question number 149. Scenario. A multi-stage pipeline must run application tests and database tests in parallel only after build succeeds. A publish results stage must wait for both tests and run after success or failure, unless the pipeline is canceled. A developer proposes stage, build stage. Application tests depends on. Stage, database tests depends on. Stage, publish results depends on. Build application tests database tests condition, succeeded or failed. Does the proposal meet all requirements? The available options are as follows. Option A, no. Option B, yes. The correct answer is option A, no. Here's why. Application tests and database tests declare empty dependency lists, so they can start without waiting for build. The publish results fan-in is configured correctly, but the test stage ordering requirement is violated. Why are the other options not correct? B. Parallel execution alone is insufficient. Both test stages must explicitly depend on successful completion of build. Exam tip. Depends on. Removes the default preceding stage dependency and makes a stage eligible to start independently. Question number 150. Scenario. A DevOps team is migrating Azure Pipelines deployments to use secretless authentication. The pipelines must deploy infrastructure to Azure without storing long-lived passwords or client secrets in Azure DevOps. Complete each statement by selecting the appropriate configuration. Statement 1. The Azure Service Connection type should be configured to use the blank. The choices for Statement 1 are Workload Identity Federation, a managed identity, or a service principal with a client secret. Statement 2. The authentication mechanism underlying this configuration relies on the blank. The choices for Statement 2 are OpenID Connect, OIDC, SAML 2.0, or OAuth 2.0 device code flow. For Statement 1, the correct selection is Workload Identity Federation. Workload Identity Federation fulfills the requirement for secretless authentication. For Statement 2, the correct selection is OpenID Connect, OIDC. Microsoft Intra Workload Identity Federation uses standard OIDC protocols to issue tokens to the automation platform. Exam tip. Choose Workload Identity Federation, OIDC, over classic service principals with secrets to eliminate credential rotation and leakage risks in pipelines. Question number 151. Scenario. A streaming company uses an Azure Pipelines YAML pipeline with the following stages. Compile API verification, which depends on compile schema verification, which depends on compile publish reports, which depends on API verification and schema verification and uses condition. Always. The two verification stages must start in parallel after a successful compile. Publish reports must run after both verification stages finish, even when either verification stage fails. Does the proposed stage dependency and condition design satisfy the requirements? The available options are as follows. Option A, no. Option B, yes. The correct answer is option B, yes. Here's why. Both verification stages depend only on compile, so they can run in parallel after compile succeeds. Publish reports depends on both verification stages and condition, always, allows it to run after they finish regardless of their results. Why are the other options not correct? A. The dependency graph and condition implement the required execution order and failure behavior. Exam tip. Dependencies control stage order. Conditions control whether a stage runs after its dependencies complete. Question number 152. Scenario. A healthcare project team is creating an Azure DevOps dashboard for its delivery project. The dashboard must show the current members of the selected team without requiring a custom query. Which dashboard widget should the team add? The available options are as follows. Option A, query results. Option B, release pipeline overview. Option C, team members. Option D, markdown. The correct answer is option C, team members. Here's why. The team members widget displays the people assigned to the selected Azure DevOps team directly on a dashboard. Why are the other options not correct? A. Query results displays work items returned by a query, not the team roster. B. Release pipeline overview summarizes release status. D. Markdown displays custom text or links and does not automatically list team members. Exam tip. Choose a purpose-built dashboard widget when Azure DevOps already exposes the required team or pipeline data. Question number 153. Scenario. A retail development team uses a classic Azure Pipelines build definition. A build must be queued automatically whenever a developer commits code to the configured repository. The pipeline owner enables continuous integration in the build pipeline trigger settings. Does this configuration meet the requirement? The available options are as follows. Option A, no. Option B, yes. The correct answer is option B, yes. Here's why. Enabling continuous integration on the build pipeline causes repository changes that match the configured filters to queue builds automatically. Why are the other options not correct? A. A separate release trigger is not required to start a build after a code commit. Exam tip. A CI trigger starts a build from source changes. Deployment triggers control releases after build output exists. Question number 154. Scenario. A payment processing team wants defects such as unused variables, unreachable code, and unsafe coding patterns to be detected before an application package is promoted to any deployment environment. During which pipeline phase should static code analysis normally run? The available options are as follows. Option A, production release. Option B, build and continuous integration. Option C, staging validation. Option D, post-deployment monitoring. The correct answer is option B, build and continuous integration. Here's why. Static analysis examines source or compiled artifacts without executing the deployed application, so it should run early in the build to provide fast feedback and block low-quality changes. Why are the other options not correct? A. Production release is too late to discover code quality defects. C. Staging is intended for deployment validation and runtime testing. D. Post-deployment monitoring observes running systems rather than analyzing source code. Exam tip. Shift static analysis left into CI, reserve later environments for runtime, integration, and acceptance validation. Question number 155. Scenario. A platform team operates an RBAC-enabled Azure Kubernetes service cluster that supports the Azure Container Instance's virtual nodes integration. The team wants selected burst workloads to run on the virtual node. Select and arrange the 3 required actions in the correct order. The available items are as follows. Item 1. Apply the workload manifest by using kubectl. Item 2. Install the Helm client on an administrator workstation. Item 3. Enable the Virtual Nodes add-on for the AKS cluster. Item 4. Create a Kubernetes manifest that includes the virtual node selector and required toleration. Item 5. Create an unrelated ACR pull role assignment for a registry that is not used by the workload. The correct sequence is as follows. First, enable the Virtual Nodes add-on for the AKS cluster. Second, create a Kubernetes manifest that includes the virtual node selector and required toleration. Third, apply the workload manifest by using kubectl. Here's why. The AKS integration must exist before a workload can target the virtual node. The manifest then identifies the virtual node through its selector and toleration, after which kubectl can create the workload. Exam tip. Provision the target execution capability before applying a manifest that schedules workloads to it. Question number 156. Scenario. An Azure DevOps administrator must assign least privilege agent pool roles. One engineer needs organization-level visibility into a pool and its agents. A project team must be able to select and consume the corresponding project pool in build and release pipelines. Map each required role to the appropriate permission scope. 2 roles will not be used. The available source items are as follows. Source item 1, administrator. Source item 2, reader. Source item 3, Service account. Source item 4. User. The destination requirements are as follows. Destination A. Organization-level role for viewing the agent pool and its agents. Destination B. Project-level role for using the agent pool in pipelines. The first correct mapping is reader, mapped to organization-level role for viewing the agent pool and its agents. The second correct mapping is user, mapped to project-level role for using the agent pool and pipelines. Here's why. The reader role can inspect an organization agent pool and its agents without administering it. The user role on the project pool permits pipelines in that project to use the pool. Exam tip. Separate pool visibility from pool consumption and assign the lowest role at the required scope. Question number 157. Scenario. A GitHub organization must implement automated security scanning to protect its repositories. Match each GitHub advanced security feature with its primary capability. The available source items are as follows. Source item 1. Secret scanning. Source item 2. Dependabot alerts. Source item 3. Code scanning. The destination requirements are as follows. Destination A. Blocks or detects exposed hard-coded credentials. Destination B. Identifies vulnerabilities in third-party open-source packages. Destination C. Analyzes first-party source code for issues such as SQL injection using CodeQL. The correct mapping is secret scanning leads to A. Dependabot alerts leads to B. Code scanning leads to C. Here's why. Secret scanning prevents and detects credential leakage. Dependabot identifies known vulnerabilities and dependencies, SCA. Code scanning, powered by CodeQL, analyzes source code for vulnerabilities like SQL injection or cross-site scripting, SCSD. Exam tip. Distinguish Dependabot, third-party dependencies, from code scanning/CodeQL, first-party code. Question number 158. Scenario. A self-hosted Azure Pipelines agent runs on an Azure virtual machine. Its network security group must permit the agent to communicate with Azure DevOps over the required web protocol while blocking all other internet ingress and egress. Which NSG design best satisfies the requirement? The available options are as follows. Option A. Add a higher priority outbound allow rule for TCP 443 to the required Azure DevOps endpoints. Add a lower priority outbound deny rule for other internet traffic and keep internet inbound traffic denied. Option B. Allow inbound and outbound TCP 443 from the entire internet and rely on the default rules for all remaining traffic. Option C. Allow outbound TCP 80 and 443 to the internet and add only a custom inbound deny rule. Option D. Create the outbound deny rule with a higher priority than the outbound TCP 443 allow rule. The correct answer is option A. Add a higher priority outbound allow rule for TCP 443 to the required Azure DevOps endpoints. Add a lower priority outbound deny rule for other internet traffic and keep internet inbound traffic denied. Here's why. Azure DevOps Web Access and normal agent communication require outbound HTTPS. NSG priority must allow that traffic before a broader deny rule blocks all remaining internet egress. Why are the other options not correct? B. Allowing internet-originated inbound HTTPS exposes the agent unnecessarily. C. TCP/80 is not required for normal Azure DevOps HTTPS communication and broad internet egress violates the requirement. D. A higher priority deny rule would block the later TCP 443 allow rule. Exam tip. NSG rules are evaluated by priority. Place specific required allows before broader deny rules. Question number 159. Scenario. A logistics company delivers Android and iOS applications through an Azure DevOps workflow. The replacement solution must distribute pre-release builds to testers, collect crash diagnostics, and capture tester feedback as actionable work items. Which implementation should the DevOps team recommend? The available options are as follows. Option A. Use Azure Pipelines for signed builds and platform beta distribution tracks. Instrument the apps with application insights or Azure Monitor OpenTelemetry for diagnostics, and capture tester feedback in Azure boards. Option B. Integrate the retired Visual Studio App Center service as the single platform for build distribution, diagnostics, and feedback. Option C. Add Jenkins integration only and use its build console as the crash reporting and feedback system. Option D. Add Application Insights dashboard widgets only and use them to distribute mobile packages to testers. The correct answer is Option A. Use Azure pipelines for signed builds and platform beta distribution tracks. Instrument the apps with Application Insights or Azure Monitor OpenTelemetry for diagnostics, and capture tester feedback in Azure boards. Here's why. The combination provides maintained CI/CD, supported beta distribution channels, application diagnostics, and traceable feedback without depending on a retired all-in-one mobile service. Why are the other options not correct? B. Visual Studio App Center is retired and cannot be selected as the current delivery platform. C. Jenkins alone does not provide mobile crash analytics, beta distribution, and structured tester feedback. D. Application Insights can collect telemetry but does not distribute mobile builds. Exam tip. When a bundled DevOps service retires, map each requirement to a maintained build, distribution, telemetry, and work tracking capability. Question number 160. Scenario. A DevOps architect must select version control platforms for 3 teams. One team wants pipeline YAML version with its application code in Azure DevOps. A regulated team requires a company-controlled, on-premises Git platform. A legacy team requires centralized version control rather than a distributed Git workflow. Map the most appropriate version control system to each requirement. One system will not be used. The available source items are as follows. Source item 1. Git in Azure repos. Source item 2. Bitbucket Cloud. Source item 3. GitHub Enterprise Server. Source item 4. Assembly Subversion. The destination requirements are as follows. Destination A. Version pipeline YAML and application code together in Azure DevOps. Destination B. Host Git repositories on company-controlled on-premises infrastructure. Destination C. Use a centralized version control model. The first correct mapping is Git in Azure repos, mapped to version pipeline YAML and application code together in Azure DevOps. The second correct mapping is GitHub Enterprise Server, mapped to host Git repositories on company-controlled on-premises infrastructure. The third correct mapping is Assembly Subversion, mapped to use a centralized version control model. Here's why. Azure repos Git versions pipeline YAML beside application code. GitHub Enterprise Server supports company-controlled Git hosting. Subversion uses a centralized repository model. Exam tip. Distinguish repository location requirements from the fundamental distributed versus centralized version control model. Question number 161. Scenario. A .NET Framework solution is built in Azure pipelines and includes unit tests. SonarQube must analyze the C# source and include test and coverage information in the analysis. Select and arrange the 4 required pipeline tasks in the correct order. The available items are as follows. Item 1. Publish the compiled binaries as build artifacts. Item 2. Run the unit tests and collect coverage data. Item 3. Prepare the SonarQube analysis configuration. Item 4. Build the Visual Studio solution. Item 5. Run the SonarQube code analysis task. The correct sequence is as follows. First, prepare the SonarQube analysis configuration. Second, build the Visual Studio solution. Third, run the unit tests and collect coverage data. Fourth, run the SonarQube code analysis task. Here's why. SonarQube preparation configures the scanner before compilation. The build supplies analyze binaries, tests produce coverage data, and the final analysis step processes the collected information. Exam tip. For .NET analysis, prepare before the build and finalize analysis only after build and test data are available. Question number 162. Scenario. An operations team uses Azure Automation State Configuration to detect and report configuration drift on a group of virtual machines. Select and arrange the 5 required actions in one valid implementation order. The available items are as follows. Item 1. Assign organizational tags to the virtual machines. Item 2. Review the compliance status reported for each node. Item 3. Upload the DSC configuration to the automation account. Item 4. Create an Azure management group. Item 5. Compile the configuration into a node configuration. Item 6. Assign the node configuration to the registered nodes. Item 7. Onboard the virtual machines as state configuration nodes. The correct sequence is as follows. First, upload the DSC configuration to the automation account. Second, compile the configuration into a node configuration. Third, onboard the virtual machines as state configuration nodes. Fourth, assign the node configuration to the registered nodes. Fifth, review the compliance status reported for each node. Here's why. A DSC source configuration must be imported and compiled into a node configuration. Machines are then registered, assigned that node configuration, and evaluated for compliance. Exam tip. A DSC source configuration is not assignable until it has been compiled into a node configuration. Question number 163. Scenario. A classic release environment requires approval from an operations lead. The approval policy allows 6 hours, but releases currently fail when no response is received within 90 minutes. The release administrator changes the timeout for the environment's pre-deployment approval to 6 hours. Does this change meet the requirement? The available options are as follows. Option A. No. Option B. Yes. The correct answer is option B. Yes. Here's why. The pre-deployment approval timeout controls how long the release waits for the required approval before the deployment is rejected or times out. Why are the other options not correct? A. Changing an unrelated task or deployment timeout would not extend the approval response window. Exam tip. Configure approval timeouts on the approval check itself, not on the deployment tasks that run after approval. Question number 164. Scenario. A release pipeline must deploy compute resources to one resource group and database resources to another resource group. Each deployment is performed at resource group scope. The team creates 2 independently versioned ARM templates and deploys each template to its corresponding resource group from the same release pipeline. Does this approach satisfy the deployment requirement? The available options are as follows. Option A. Yes. Option B. No. The correct answer is option A. Yes. Here's why. A resource group scoped ARM deployment can target one resource group. Deploying one template per resource group is a valid way to create and manage the 2 resource sets from one pipeline. Why are the other options not correct? B. A single monolithic template is not mandatory when resources are deployed to separate resource group scopes. Exam tip. Match an ARM or bicep deployment scope to the resources it creates. Pipelines can orchestrate multiple scope deployments. Question number 165. Scenario. A subscription requires every resource group to contain the tag cost center with the value R&D. The policy must add or correct the tag and allow remediation of existing resource groups. Complete the Azure policy design by selecting the appropriate value for each statement. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. The policy condition should target resources whose type is the blank. The choices for Statement 1 are Microsoft, resources/subscriptions/resource groups, Microsoft, resources/deployments, or Microsoft, resources/subscriptions. Statement 2. The policy should use the blank effect to update the tag and support remediation. The choices for Statement 2 are Modify, Deny, or Audit. Statement 3. The tag operation should use the blank so an incorrect existing value is replaced. The choices for Statement 3 are Add or Replace, Remove, or Add. For Statement 1, the correct selection is Microsoft, resources/subscriptions/resource groups. This is the Azure resource type for resource groups. For Statement 2, the correct selection is Modify. Modify can alter tags and remediate existing non-compliant resources through a managed identity. For Statement 3, the correct selection is Add or Replace. The operation creates the tag when absent and replaces a conflicting value. Exam tip. Use modify with add or replace for remediable tag enforcement. Deny only blocks non-compliant requests. Question number 166. Scenario. A customer-facing service has a high business impact. A small group of customers has opted in to evaluate each release before wider exposure. A second service requires near-instant traffic cutover and the fastest possible rollback to the previous version. Map the appropriate deployment strategy to each requirement. One strategy will not be used. The available source items are as follows. Source item 1, rolling deployment. Source item 2, blue-green deployment. Source item 3, canary deployment. The destination requirements are as follows. Destination A, expose the release first to a small opt-in cohort. Destination B, switch traffic between two complete environments for rapid rollback. The first correct mapping is canary deployment. Map to expose the release first to a small opt-in cohort. The second correct mapping is blue-green deployment. Map to switch traffic between two complete environments for rapid rollback. Here's why. Canary deployment limits initial exposure to a small audience. Blue-green deployment maintains two complete environments and enables fast traffic switching back to the previous version. Exam tip. Canary controls exposure gradually. Blue-green optimizes cutover and rollback between full environments. Question number 167. Scenario. A development team must publish a private NuGet package to Azure artifacts and verify that another project can restore it. Select and arrange the 4 required actions in the correct order. The available items are as follows. Item 1. Configure a dedicated self-hosted build agent even though no private network dependency exists. Item 2. Install the package from the feed in a test project. Item 3. Create a private Azure Artifacts feed. Item 4. Connect to the feed as an authenticated NuGet source. Item 5. Publish the NuGet package to the feed. The correct sequence is as follows. First, create a private Azure Artifacts feed. Second, connect to the feed as an authenticated NuGet source. Third, publish the NuGet package to the feed. Fourth, install the package from the feed in a test project. Here's why. The feed must exist before clients authenticate to it. After the package is published, a consuming project can install or restore it to verify availability. Exam tip. A private package workflow requires a feed, authenticated connectivity, publication, and then consumption validation. Question number 168. Scenario. A team must create an RBAC-enabled AKS cluster by using a newly created custom service principal and then connect kubectl to the cluster. Select and arrange the 3 required Azure CLI actions in the correct order. The available items are as follows. Item 1. Run AZ role assignment create for an unrelated resource group. Item 2. Run AZ AKS get credentials for the new cluster. Item 3. Run kubectl create before the cluster exists. Item 4. Run AZ add SP create for RBAC and capture the application ID and client secret. Item 5. Run AZ AKS create and supply the custom service principal credentials. The correct sequence is as follows. First, run AZ add SP create for RBAC and capture the application ID and client secret. Second, run AZ AKS create and supply the custom service principal credentials. Third, run AZ AKS get credentials for the new cluster. Here's why. The application ID and secret must exist before AZ AKS create can use them. kubectl connectivity is configured only after the cluster has been provisioned. Exam tip. Create authentication material before provisioning the resource that consumes it, then configure client access after deployment. Question number 169. Scenario. A product team uses application insights to understand feature adoption and how application performance influences user behavior. Map each application insights usage tool to the question it is designed to answer. The available source items are as follows. Source item 1. Users. Source item 2. Impact. Source item 3. User flows. The destination requirements are as follows. Destination A. How do users navigate between pages and features? Destination B. How many distinct people use the application or a feature? Destination C. How does page or feature performance affect usage? The first correct mapping is user flows, mapped to how do users navigate between pages and features. The second correct mapping is users, mapped to how many distinct people use the application or a feature. The third correct mapping is impact, mapped to how does page or feature performance affect usage. Here's why. Each application insight's usage experience is optimized for a distinct question: navigation paths, user counts, or the relationship between performance and adoption. Exam tip: use user flows for paths, users for adoption counts, and impact for performance to usage correlation. Question number 170. Scenario: you are designing a solution for an investment planning application suite. You need to configure a cloud service to store the secrets required by the mobile applications to call the share pricing service. What should you include in the solution? Complete the configuration by selecting the appropriate options. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Required secrets, the blank. The choices for Statement 1 are certificate, personal access token, shared access authorization token, or username and password. Statement 2. Storage location, the blank. The choices for Statement 2 are Azure Data Lake, Azure Key Vault, Azure Storage with HTTP access, or Azure Storage with HTTPS access. For Statement 1, the correct selection is Shared Access Authorization Token. SAS tokens provide delegated, time-bound access to resources, making them ideal for mobile application integrations. For Statement 2, the correct selection is Azure Key Vault. Azure Key Vault securely stores and tightly controls access to secrets and tokens. Exam tip: always use Azure Key Vault to store credentials, certificates, and tokens securely rather than storing them in code, standard storage accounts, or data lakes. Question number 171. Scenario: you are configuring Azure pipelines for an investment planning application suite. Where should the build and release agents for the investment planning application suite run? Complete the configuration by selecting the appropriate options. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Build agent, the blank. The choices for Statement 1 are a hosted service, a source control system, or the developer's computers. Statement 2. Release agent, the blank. The choices for Statement 2 are a hosted service, a source control system, or the developer's computers. For Statement 1, the correct selection is a hosted service. Microsoft hosted agents reduce maintenance and automatically provide fresh environments for builds. For Statement 2, the correct selection is a hosted service. Microsoft hosted agents are securely managed and scale automatically for release tasks. Exam tip: default to Microsoft hosted agents for Azure pipelines unless private network connectivity, specific cache states, or unsupported custom software strictly dictate using self-hosted agents. Question number 172. Scenario: a Java build in Azure DevOps must retrieve dependencies from an internal repository that is reachable only from the corporate network. Source code is stored in Azure repos, and build output must be published as Azure DevOps server artifacts. The proposed solution installs an Octopus tentacle on an internal server and uses an Octopus package application task as the build integration. Does the proposed solution satisfy all requirements? The available options are as follows. Option A: yes. Option B: no. The correct answer is Option B: no. Here's why. An Octopus tentacle is a deployment worker, not an Azure Pipelines build agent that satisfies the private dependency requirement. The proposed package task also does not publish the required Azure DevOps server artifact. Why are the other options not correct? A. The solution omits a suitable Azure Pipelines agent and the required Azure DevOps artifact publication mechanism. Exam tip: use a self-hosted Azure Pipelines agent for private network dependencies and the appropriate Azure DevOps artifact task for build output. Question number 173. Scenario: a virtual machine scale set hosts a stateful internal web application. Application installation is controlled by a custom script extension whose script is stored in Azure Storage. The scale set uses a manual upgrade policy, and an existing administrative endpoint allows testers to reach a selected instance. A small UI change must be deployed to one instance for limited evaluation before the remaining instances are updated. Which 3 actions should the DevOps engineer perform? Select exactly 3 answers. The available options are as follows. Option A. Upload the revised installation script to the storage account. Option B. Update the scale set model so the custom script extension references the revised script. Option C. Apply the latest scale set model to one selected virtual machine instance. Option D. Reimage every instance in the scale set immediately. Option E. Replace the existing load balancing configuration before changing the extension. The correct answers are Option A. Upload the revised installation script to the storage account. Option B. Update the scale set model so the custom script extension references the revised script. And Option C. Apply the latest scale set model to one selected virtual machine instance. Here's why. The new script must be available. The scale set model must reference it, and manual instance upgrade allows the change to be applied to only the selected test instance before broad rollout. Why are the other options not correct? D. Reimaging every instance eliminates the limited test rollout and creates unnecessary disruption. E. The existing administrative route already reaches the selected instance, so replacing load balancing is not required. Exam tip. With a manual VMSS upgrade policy, update the model first and then upgrade selected instances for controlled exposure. You have completed Part 4 of the AZ-400 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.